Let's do section 11.3, page 565, exercise 53, which reads, find the area of the region described. And for exercise 53, the region is shared by the circle r equals 2 and the cardioid r equals 2 times 1 minus cosine theta. So we want to begin by graphing. So here are my axes, and I'm going to have a circle. So this is going to be r is equal to 2. And then I'm going to have my cardioid, which kind of looks like this. And the region that I'm concerned with finding the area of is going to be all of this here. And there are a couple of complications. So for instance, this point up here is going to be theta equals pi over 2. And this point over here is going to be theta equals pi. My first problem is that half of my area lies below the x-axis, and if it's negative, everything may cancel out. So I'm going to start by only focusing on the area above the x-axis, and then I will double whatever area I find. Now we have to remember that the formula that we have in this section for finding the area of a region is A is equal to the integral from alpha to beta of 1/2 times r squared, or f of theta, times d theta. But this region that we're finding the area of exists between the origin and a curve. So on this side over here, as we go from theta equals 0 to 2 pi, the curve that we're talking about is the cardioid. And as we look at this region over here, which goes from theta equals pi over 2 to theta equals pi, now we're looking at the area between the origin and the curve r equals 2. So we're going to have to break this down into two separate integrals. And then I'm going to double the whole thing because I'm only finding the area above the curve. So this is going to be equal to 2 because I'm going to double it all. And I'm going to start by going from 0 to pi over 2, which again is going to be this area here. So it's going to be 1/2. And for r, I'm going to use the formula for my cardioid, which is going to be 2 times 1 minus cosine theta. And that whole thing is going to be squared times d theta plus this area over here again, which is going to be the integral from pi over 2 to pi, and again I will have a 1/2, and now for my r squared I'm going to substitute in 2 and square it times d theta. So I'm going to start by canceling this 2 with these 1/2, and then basically I'm just going to square what I need to square. So I'm going to end up with the area is equal to the integral from 0 to pi over 2. I'm going to square this 2 and bring it outside so it's a 4. And then I've got 1 minus 2 cosine theta plus cosine squared theta d theta plus the integral from pi over 2 to pi, and I'm going to square this and get 4 d theta, and I will be able to integrate this term by term. So I'm going to have a 4 out here times, when I integrate 1 d theta, I'm going to get theta. When I integrate cosine theta, I'm going to get sine theta. And then the cosine squared theta is a little more complicated, but if you look up the integral of cosine squared theta d theta in the integral table in the back of your book, which is section A7, then you will find that that integral is theta over 2 plus sine 2 theta over 4, and we're going to evaluate this from 0 to pi over 2. And then the integral of 4 d theta is going to be 4 theta, and we're going to integrate that from pi over 2 to pi. And we're ready to substitute in our limits of integration. So I'm still going to keep my 4 out here, and I'm going to substitute in pi over 2. So I'm going to have pi over 2 minus 2 times the sine of pi over 2, which is 1, plus pi over 2, which is going to give me pi over 4, plus, when I substitute in here, this is really going to give me the sine of pi, which is going to be 0. So this was my upper limit, and I think you can see with a quick inspection that when I substitute in 0, every term in here is going to be 0. And then I can substitute my limits into the 4 theta. So I'm going to have 4 times pi, which is going to give me 4 pi, minus 4 times pi over 2, which is going to give me 2 pi. And I can do a little algebra here. And I'm going to end up with 2 pi minus 8 plus pi, and then this is going to give me another 2 pi. And so I'm going to end up with 5 pi minus 8.